Once again, welcome to the LJ Institute of Engineering and Technology. Let's start with our course Mathematics 2, and chapter is first order ordinary differential equations. And today's topic is homogeneous differential equation. So what is homogeneous differential equation? Before that, first we will understand what is homogeneous function, and which already we studied in our first semester. Okay, so first we'll take the definition of homogeneous function. Any function f of x comma y, that means either polynomial or non-polynomial, in two variable x and y is said to be homogeneous function of degree n, where n belongs to R, if f of tx comma ty is equal to t raised to n f of x comma y, then we can say that given function is homogeneous function. Okay, and this d is any positive number. Or if we have this function is transcendental function, then if we can write this function in this form, then we can say that this is homogeneous function with degree n. Okay, this definition already we studied in first semester in partial derivative chapter. Okay, same concept for homogeneous function. Now we will use this concept for homogeneous differential equation. So which kind of differential equation called homogeneous differential equation? So differential equation m of x comma y dx plus n of x comma y dy is equal to 0 is said to be homogeneous if m of x comma y and n of x comma y both are homogeneous function of same degree in x and y. So if these two functions are homogeneous function with same degree, then this entire differential equation is called homogeneous differential equation. And this kind of homogeneous differential equation is solved by reducing it into variable separable. For that, we have to just put y is equal to dx. That means if we convert this equation in dy by dx is equal to this form f of x, m of x comma y upon n of x comma y, then we will use this y is equal to vx. By differentiating and by putting this value here and put y is equal to vx in the right hand side, after simplifying we have same concept as variable separable. If we reduce this equation in this form, dx by dy is equal to, okay, then we will suppose this x is equal to vy. So you can use either of these two, both will give you same answer. Okay, so let's start with the example so you can understand better. So here we have this example. Now you can find that we don't have that particular form m of x comma y dx plus n of x comma y dy is equal to 0, but we have this directly form, and you can see that y by x is the common, and here this term has degree. If we replace tx and ty instead of x and y, so tt cancel out, so we have this as it is, and tt cancel out and we have this as it is, so we have function as it is. So this is our homogeneous function, okay, with degree n is equal to 0. So we'll start with this equation by supposing y by x is equal to v. So y by x is equal to v, so y is equal to vx, and by differentiating dy by dx is equal to, by using product rule, v as it is, differentiation of x is 1 plus x as it is, differentiation of v is dv by dx, because we are differentiating with respect to x. Now we will replace this value in equation 1, and this value is also in equation 1. So we have equation 1 becomes v plus x dv by dx. This is our v and tan v. Now we can cancel out this v, so we have x dv by dx is equal to tan v. Now we can separate the variable. So we have variable separable, reduced to variable separable, homogeneous and non-homogeneous. All four will solve by only one method, variable separable. Before that, we have to just start with some basic concept or simple basic these steps. After that, we have to use variable separable. Okay, so we'll take 10v on the left hand side and this x upon dx on the right hand side. So it's become this dv upon 10v is equal to this on the right hand side. So dx on the numerator, x on the denominator. Now, before write down that taking integration on both sides, before we have to just check it is integrable or not. So 1 by x is integrable because 1 by x integration of 1 by x is log x. What is the integration of 10? We don't 1 by 10 we don't know. So we'll just use trigonometry. So we have cot v and then we'll integrate. So cot v dv integration of cot v and integration of 1 by x. So we know that integration of cot v is log sine v, integration of x is log x, and as I told, whenever we have log in the integration, we will use constant is also log c. So by using concept of log, log that means ln sine v is equal to ln x into c. Can by taking antilog on both sides, we have sine v is equal to x c, and we will put the value of v is y by x, which is our general solution. This is our final general solution. Okay, this is simple example I have taken. Now we have the particular example which just look like as exact homogeneous. So here you can see that this is our m of x comma y, this is n of x comma y. This term has power 4 total power. This also have total power 3 plus 1 is 4. This term is also power 4. This term is also power 4. So as directly without any definition of this, if we have this kind of differential equation in which each term has the same degree, except this dx and dy, don't include this dx and dy, other than that each term has the same degree, then that is the homogeneous differential equation. Okay, and whenever we have homogeneous differential equation, we will convert it into this form, dy by dx is equal to this, or you can convert into dx by dy as I told. But if we convert in dy by dx, then we will suppose y is equal to vx, that means y by x is equal to v. And if we reduce in dx by dy, so this term reversible, that means reciprocal of that, and we will suppose x is equal to vy, that means x by y is equal to v. Okay, so choice is yours, answer will same. Okay, so we have y is equal to vx, so y by x is equal to v, and by differentiate this is common step. Okay, and we will put the value y here, vx and vx, and instead of dy by dx we have v plus x dv by dx. So equation 1 becomes this, and now we know that vx whole raised to 4, that means v raised to 4 x raised to 4, and by multiplying this we have 2v x raised to 4 same as in denominator. So you can find that each power of x is equal. So we can take x raised to 4 common from the numerator same as in the denominator, and by cancel out we have remaining term is this. After putting the value y is equal to vx and value of dy by dx, just we have to take common maximum x. So x will be removed from the right hand side and we will take v on the right hand side after cancel out the x. So we have minus v, and now we'll take LCM of right hand side, so left hand side as it is, LCM of this, so this multiply with the v, so we have this term, because of this minus sign will be changed, and by simplify minus 2 raised to 4 v raised to 4 v minus v raised to 4 and minus 2v plus v minus v, and this as it is. Now we can separate the variable because this entire term is of v, so we can take with this dv and this will take on the right hand side. Before that we'll just take common this minus and give to the denominator, so this minus will not make trouble in future. So by taking variable separable, now this term goes on the left hand side, so numerator become denominator and denominator become numerator. So we can take v common from this, so we keep plus 1. Now this is not directly integrable, so we have to just factorize this v cube plus 1. So we have factor of this v cube plus 1 is v plus 1, v square minus v plus 1. Now this is not integrable directly, so first we will split this denominator, these three factors, by using partial fraction method. So we have partial fraction method, we all studied in 12th standard. So this equal to 1 by v, these are the linear, this is linear factor, so 1 by v, b a by v, b by v plus 1, and this is quadratic factor, so we'll use cv plus d. Okay, we all studied. Now then we will multiply this entire term with a, b and c, entire term with a, so v cancel out, so we have left hand side this as it is, and a is multiplied with this two term, that v plus 1 and v square minus v plus 1 become v cube plus 1. Now when we multiply this entire with b, so v plus 1 cancel out, so b into v into this two factors, and same as this entire term is multiplied with this 2, because now if we multiply this entire term here, okay, so v square minus v plus 1 cancel out, so we have this. Now we know the method. First we will put v is equal to 0, then we will put v is equal to minus 1, then we cannot find the value of v from here, so we will compare the coefficient of different power. So first we will put v is equal to 0 in this equation, so this 0, so left hand side 1, v0, because of v0 this 0 and this is 0 entire, so we have a 0 plus 1 is 1, so a is equal to 1. Similarly, we put v is equal to minus 1. So minus 1 cube is minus 1. So this become a plus. 1 plus 2 is 3. And because of minus 1, this is 0 and this is 0. So v, and this is minus 1 and this 1, 1 and 1. It's 3. 3 they cancel out. So v is equal to minus 1. Now we cannot put more value of v. So we have this our equation. And by comparing, as I told, both sides, the coefficient of like power of v. So we'll start with the maximum power of v. So we have v cube is the maximum power of v, and we'll just find out the coefficient of v cube. So coefficient of v cube is a. If we expand this, the coefficient of v cube is b, and if we expand this, the coefficient of v cube is c. So a plus b plus c. Now left hand side, the coefficient of v cube is minus 2. So a plus b plus c is equal to minus 2. We know the value of a is 1, b is minus 1, so this is 0 and c is minus 2. Now we will compare the coefficient of v square, because we already compare the coefficient of v cube, so coefficient of v square. So by again expanding this, we multiply with v, give the v square, so minus b. Similar way, if we multiply this v here, so v and this v, so plus c, and this v square plus d, minus b plus c plus d, and on left hand side we don't have a v square, so 0. Now we have value of b is minus 1, so minus minus plus, value of c is minus 2, so we get the value of d. Now we have all the value a, b, c, d, so equation 2 becomes this: a is 1, b is minus 1, this c, and this is d. Okay, c is minus 2, d is 1, but we just take minus common, so this becomes. Now you can observe that integration of 1 by v log is log, and differentiation of this in the numerator, so we have log. So by integrating both sides, log v, log 1 plus v, by integrating both sides, we have log v, log 1 plus v, log v square minus v plus 1, because this rule, and log x and plus x. So we have rule of logarithm. This minus minus goes in the denominator, and we know this is our v cube plus 1. So we will put that value, but it cancel out log on both sides, that means taking any log on both sides. And after this we have to just put the value of v, which is our y by x. Okay, and by simplifying we have, this is our final answer, which is our general solution. And similar way we have this DIYs. Here, as I told, as I have given one important logic, that you have to just check each and every term has the same degree. So this term has a 3 degree, 3 degree, 3 degree. Similar way, this term has a 3 degree, 3 degree. If you multiply here, so 1113 multiply here, so 1113. Don't include this dx and dy. Okay, so this 2 2 and this 2. Here we have 1 1 1 1. Okay, we have 3 3 3 3. We have 2 2 2 2. Some of example directly you can see, and remaining these two example you can see that x by y is the common. So suppose x by y is equal to b, and in this example y by x is common. So suppose y by x is equal to b. Okay, so in homogeneous, what we have seen, so first after supposing that y by x is equal to v or x by y is equal to v, by simplifying we have the reduced to variable settlement method. Okay, so please try to solve this each and every example, so you will understand better next method, non-homogeneous differential equation, which is not that much important, but we have to, because we have to learn, because if in exam if it is asked, then you should know about that method. Okay, so thank you for today's lecture. We will see you soon with another method, non-homogeneous differential equation. So thank you.